I think this would be a great title for like a top 40 song. I was only a scalar, and then you came into my life and gave me direction. You are my vector of my heart. Wouldn't that, something like that? Wouldn't that be? Nothing? Really? You can't see Justin Bieber just crooning that out? Nothing. Okay. We're going to be talking about components. Start off with a little bit of review. A person walks 6 meters north and 4 kilometers east. You know what? They threw a compass there. I'm going to put a compass rose somewhere on here because it's not like I've messed that up before. What's their distance traveled? And you'll notice I didn't leave you much room because you shouldn't need much room. What's the distance this person traveled? 10 kilometers. Direction, scalar. What's their displacement, magnitude, and direction? I guess I want to add these two vectors together. How will I add them together? Draw them tip to tail. Let's see if we can do this without doing the rough copy. So last day we drew the individual lines, wrote an equal sign, and then we drew the triangle. Let's see if we can just add them tip to tail. It's going to be 6 north, and then 4 kilometers which way? East, which is going to be to the right, and 4 compared to 6, about 2/3 as long-ish. Maybe like that. And the resultant is going to be from the tail of the first to the tip of the second. Theta is going to go right there. Since they called it displacement, I'll label the resultant with the letter D and the vector symbol for displacement. May as well, Nate, use their terminology. What's the magnitude of the displacement? It's going to be 10 squared plus 4 squared. It's going to be a square root of 116. It's going to be 10.7 is a guess.
10.8.
10.8? Yeah, I was off by 1 decimal. So again, I hope you're okay in handling Pythagoras. And again, if you want to, that's totally wrong. I went 6 squared plus 4 squared. I'm totally wrong. It's 6 squared. I said 10 squared. 6 squared plus 4 squared, it's going to be 64 plus 16. It's going to be the square root of 36 plus 16. Wow, Duick. Are you in terrible form? You know what? I'm putting this lesson on YouTube just to show my shame for not being able to do math in my head. 6 squared is 36. 4 squared is 16. 36 and 16 is going to be the square root of 52, which is going to be 7 point something. 7.1 or 7.2? 7.2? Wow, I was totally off. 7.21. Units, kilometers. Direction. That 4, opposite, adjacent, or hypotenuse? Opposite. What about that 6? I figured it was going to be tan because I'm finding a hypotenuse, and it's usually tan when I do that. Tan theta is going to be opposite over adjacent. (33.7 degrees). North of south, east of west, what of what? East of north or north of east? Because that's really what it comes down to usually in these, right? Okay, this is east of north. Good. Good. How do we add two vectors together, Sarah? Draw them. How do we subtract vectors? Honestly, the short answer is we don't. There is a method to subtracting vectors. There is a new procedure. And if you're bored, sometime come by in a flex and I'll show you that it does work. But rather than learning an entirely new procedure, Sarah, how do I add two vectors together? Why don't I figure out a way to turn a subtraction into an addition? And then I can use the rule I've spent so much time flogging to death. So instead what we do the opposite. We make use of this handy-dandy mathematical fact. 5 take away 3 is the same as 5 plus the opposite of 3. And you'll notice I phrased that carefully. I didn't say 5 plus negative 3. I said even more generically, that symbol in front of a term means its opposite. So in symbols, vector A, take away vector B, we're actually going to go vector A plus the opposite of vector B. What would the opposite of vector B be? If vector B was west, the opposite would be east. If vector B was north, the opposite, south. So the first vector stays the same. We opposite the second one. And then we can add them tip to tail, because now it's an addition question. So I've turned the page. I'm going to stick a compass rose here somewhere, because, I need to. If force 1 is due west and force 2 is due north, what's force 2 minus force 1? I'm not going to solve that. I'm going to say this is force 2 plus the opposite of force 1. And since this is new and this is subtraction, I think, Lyndon, I will draw this out. Lyndon, what's force 2, magnitude and direction, please? Yeah, I think I'm using newtons on purpose, and I'll also use watts, except watts is a scalar, so it's not as big an issue. Newtons 12, north 12, plus, read to me F1 as I wrote it. Don't worry about the opposite yet. Just read to me F1 magnitude and direction. Direction. West. So what would be the opposite of 6.8 west? This is what I'll do. My scale's a bit bad. 12 is roughly twice as big as 6, so I'm just going to make my 12 a bit longer just so that it looks better. And what started as a subtraction question, Kyle, is now an addition question. And Kyle, how do I add two vectors together? Draw them. There you go. So it's going to be 12, 6.8. And then the same rule, the resultant is from the tail of the first to the tip of the second. And this would be F2 take away F1, if you want to actually give it a label and say that's what it is. Which is, theta is always still where the vector's coming from. So let's figure this out. F2 minus F1 is going to be 12 squared plus 6.8 squared equals square root answer button. 13.8. Units, newtons, at, that 12 opposite, adjacent, or hypotenuse. That 6.8 opposite, it's going to be tan, what always goes next to the trig function, the angle, which in this case is theta. I told you we're going to be doing trig on a lot of questions, I think. I hope I did. 6.8 divided by 12, probably going to be around 30-ish degrees, give or take-ish. I know the inverse tangent of 1/2 is really close to 30, and 6.8 over 12 is really close to 1/2-ish. 29.5. North of south, east of west, what of what? Nate? East of north. So how do we subtract vectors? We don't. Instead, we add the opposite. We turn it into a plus negative question. And now we can add them tip to tail. Where might we use this? If momentum final is 36 kilogram meters per second north, and momentum initial is 17 kilogram meters per second east, what is triangle P with a vector? What is that triangle? Change it. What's change? An impulse, yes. What's change in anything? Did you say minus? Oh, okay. You're going to use subtraction of vectors if you're finding a change in of vectors, which you're going to do fairly often this year. So this is going to be final minus initial, except how do I subtract vectors? I don't. What do I do instead? So I'm going to go plus and then put the negative right there. I got to be fussy. I'm adding the opposite, not the inverse. Inverse means something different in math. And you're probably taking Math 12, so you want to make sure you know it. Keep it straight.
Not there yet.
Okay. Think we can do this without drawing the individual lines and go straight to the diagram? Let's see if we can. Final magnitude 36, direction north. That's not going to change. Put your pencils down, look up. A good habit to get into, and just to try and visualize what it's going to look like. If I didn't, I would have done this. 36, don't write that down. Then I would have said initial 17 east. What's the opposite ange of 17 east? 17. And now I would have gone, oh, this is now inside my triangle. It's going to clutter things up. So what I actually did is I imagined everything ahead of time, and I actually said, first of all, I'm going to need to move this line over a little bit so I got enough room to draw this, and then I can put that one going that way. So you can kind of imagine a little bit ahead of time what your triangle is going to look like, or use pencil and erase, or just not care that your number is inside the triangle. Caleb, can you put that away, kiddo? Thank you. Mine, but play with it later. Thank you. And now, here is the impulse, the change in momentum, and there's theta. Try finding the impulse, the change in momentum on your own. I'll do it up here, and let's see if we end up at the same place. I think, Jordan, yeah? Yeah. So where will you use subtraction of vectors if you're finding a change in? Because what's change in anything? Final minus initial. Oh, and my new students, if you're wondering how they all knew that, I flogged that to death last year like crazy. So I'll be flogging it to death again this year too. But anytime you see that delta, it always just means final minus initial. Hey, turn the page. Not only can I add two vectors together and get the resultant slanty line, I can break any vector up into its vertical. I'll often use a subscript y as my abbreviation for vertical. And horizontal, I'll often use a subscripted x for horizontal components. And this is going to be something else we're going to do an awful lot. So example 1, we're launching an object at an angle of 38 degrees above the horizontal at 42 meters per second. Do you see an angle? Nate, do you see an angle? You know what your next statement now is going to be in your mind? This is a job for components. We're never going to deal with angles that they give us. We're always going to break them into components. Do I see an angle? This is a job for components. Do I see an angle? This is a job for components. Now, what do I mean by that? So I've given you this picture. With your pen or pencil, I'm going to do it in red as a dotted line. You can break this slanty line up into a horizontal, I'll call it Vx, and a vertical, I'll call it Vy, component. What we're really doing is we're asking what two vectors were added together tip to tail to give us the 42 meters per second at 38 degrees above the horizontal. and we're going to find them both. Kevin, what do you want to find first, Vx or Vy? Doesn't matter.
Vy.
Okay, that Vy, what is it? Opposite, adjacent, or hypotenuse in that triangle?
It would be opposite.
Yep. And then the only other side that I know is that 42. What is it?
Hypotenuse.
No, that's okay. I've just turned the page. I'm going to be doing lots of trig. Another good habit is when you're doing this somewhere on your page, I often put a compass rose and I put that just to cut down on my silliness. I have an O and an H. Which trig function?
Sine.
What always goes next to the trig function? The angle, which I do know this time.
Yeah.
38. And that equals Vy over 42. How would I get the Vy by itself?
Multiply over the 42.
I don't want to rewrite this whole thing. You can look up. I'm perfectly fine, Kevin, if at this stage you cross that out and you just tuck the 42 in front, and that's your way of telling me that's what I'm typing into my calculator. 42 sine 38. And I get a Vy of 25.9. meters per second. No need for a direction here. Here the direction is contained in that little letter Y. Vertical. I'll clue in. Let's find Vx. Hey, Vx, opposite, adjacent, or hypotenuse? Adjacent. And I still know the hypotenuse. I have A and H. Which trig function? Cos. So if I hear you correctly, and I think I do, you're telling me that cos 38 equals Vx over 42. How would I get the Vx by itself? You know, I'm going to do the same shtick. Cross out the 42. In fact, I'm so lazy, I noticed on my calculator, I can just backspace and edit, and all I got to do is change the sign to a cos. It's even less typing. And I get a vertical component, horizontal component of 33.1. And what we're really saying is this: if we had started with, don't write this down, 33.1 and added tip to tail 25.9, if you do the Pythagoras, you'll get 42. You won't quite get 42 because we've rounded off. Maybe close. And if you did the theta, you'd get 38 degrees. Again, you won't quite get 38 degrees because we've rounded off. But we're asking now, hey, what if we can break an angle vector, a slanty vector, into components? Example 2 says, find the components of this force. We're tugging down in that direction. We start out where the vector is originating from, and we add in as dotted lines horizontal and vertical. Instead of Vx and Vy, I'll call them Fx and Fy. Mr. Dueck, could I have gone vertical first? Nothing wrong. I'll almost always do horizontal, then vertical first. I also noticed if I did it that way, I'd be running into this number and cluttering up my diagram and getting confused, and I can prevent that by going horizontal and vertical. Caleb, what do you want to find first? Fx or Fy? Doesn't matter.
Fy.
Fyi, you want to find Fy? Can you tell me Fy, opposite, adjacent, or hypotenuse?
It's opposite.
It is. What about that 39.6?
Yes.
Mm-hmm. Which trig function?
It's the one with the C. Close.
I don't think so. I got an O.
No. That was sine.
It is. It is. Come on, computer. So you're telling me sine, what always goes next, the angle 18 equals opposite over hypotenuse. How do I get the Fy by itself?
You just do the times thing.
FYI, how big is Fy? 39.6 sine 18. 12.237. I'll go to 3 sig figs. Now, if I was using this to find other stuff, I'd probably go to 5 or 6 sig figs, and we will later. But for now, 12.2 units, newtons, direction, vertical. Why? Now, it's downwards. If you wanted to, you could write the word down, or you could put a negative in front of it, or whatever. I'll write the word down. That's Fy. I'd like now to find Fx. It's going to be cosine, because it's adjacent over hypotenuse, of 18 equals Fx over 39.6. And some of you are saying, hey, Mr. Dewick, there's some nice shortcuts I can take along the way, to which I say, yep, just be careful, make sure they always work, but yep. Especially if you listen to my rant about getting a good calculator. Yep. 39.7? Sorry, 37.7? Newtons, right, positive, whatever. Is that okay? Let's see if we can apply some of this. Components can help us add vectors that are not at right angles with each other. Add 12 newtons due west and 24 newtons at 30 degrees south of west. Well, I see angles and compass directions, so I'm going to start out by doing that. Tristan, can you read to me the first vector that they gave me, magnitude and direction? So that's going to be that way. Plus south of what? South of what? Say it again. South of what? Say it again. This is the word I trigger on. So you ready? South of what? Same word. Draw a dotted line west. What of west? I'm going to drop down. This is how you draw these. I look at the word, the of blank is the dotted line that I draw, and then I move in front of the word of. That tells me to go this way. How many degrees? So about like that. How long? 24, which is going to be longer than that 14-ish. So it's going to look like that, where that angle is 30 degrees. Kind of how would I add those together? Draw them. Put your pencils down, look up. Here's the problem. If you do that, you're going to go, okay, 14, there's the tip. Okay. 24, there's the resultant, like that. Is that a right angle triangle? So you could solve this using the sine law and the cosine law. We will eventually do it that way if we so choose. But for now, do you see the problem? Why is it a problem? Because there's an angle. Do you see an angle? This is a job for components. I'm going to break this angle up into horizontal and vertical. Let's find, I don't know. Petrie, which one do you want to find first, Fx or Fy? Fx, opposite, adjacent, or hypotenuse? Yep. What about that 24? Which trig function? A and H?
Oh, no.
That was a sin. Cos. And it's going to be 30 equals fx over 24. I'm going to use this answer to find the real answer, so I'm going to carry extra sig figs here. I'm not going to round off to 3 sig figs. I only round off my very, very last step. How would I get the fx by itself? You get 20.78. I'll go 20.7846. Because there's a 0 after the 6. That seems like a nice place to stop without carrying too many decimals around. Fy, opposite. Which trig function? O and H. Sine? In fact, you know what? Have you spotted the pattern? Looking at the previous, I think it's going to be 24 sine 30 equals Fy. Does that make sense, Tristan? I think that's what we've been, it's been pretty repetitive. Yeah? It'll be Fy over the 24. We multiply the 24 over 12, yes? 12 even. So here's really what I have. $14 plus 12 plus 20.7846. Why is that nicer? Mr. Dewick, it's 3 vectors. 3 vectors is yuckier, isn't it? Or is it? 2 of those vectors, I'm going to argue, are really nice. Oh, so what you're really telling me is this is going to be, the 12 still stays there. But what can I combine those other 2 vectors to be? What if they were pointing in opposite directions? I would go winner minus loser. I wouldn't worry about doing vector subtraction. I just go winner minus loser. Okay? So I can turn it, using components, I can turn slanties into 2 nice vectors. This is going to be 34.7846, is that right? And now I have 2 vectors. McKenna, full circle. How do I add 2 vectors together? Draw them. There we go. So it's going to be 34.7846. I guess the 12 is going to be pretty short compared to that. And the resultant is going to be right there. Hey, now I'm in familiar territory. A little Pythagoras, a little shift sine, cos, or tangent, and away I go. Theta is going to go there. So the resultant is going to be $36.8. Now, final answer, I'll go to 3 sig figs. Is it 36.8? Anybody else? Yeah. Yep. Newtons at opposite, adjacent, tan theta is going to be 12 over 34.7846. 12 over 34.7846. And I get 19 degrees. North of south, east of west, what of what? West of south? I think it's south of west, isn't it? Yeah? By the way, this is an A minus level question, okay? Giving you a non-right angle, yucky. What would be an A plus level question? Adding 2 slanties, which you would break both into components. combine all the verticals, combine all the horizontals, combine all the north-souths, combine all the east-wests. Now you've turned it into 2, add those 2 tip to tail. I think there's some like that in the homework. I'm not going to give you one like that on a test or a quiz. Too much work. I think 2 more, we're done. 2 more, we're done. Did you all just turn the page? I see the word east. I see angles. There. Plane's engine speed is 240 meters per second due east. Crosswind is blowing at 125 meters per second at 40 degrees north of west. What's the plane's velocity relative to the ground? Okay, this is where, and I think I gave you this equation on your formula sheet, it's going to be V engine plus V wind. That's what gives you the resultant on the ground. Whichever way the plane is pointing plus whichever way the wind is blowing is what gives you your actual ground speed. They call it ground speed. I think I did in my rant how it should be called ground velocity, but they use scalar language for among pilots. Oh, by the way, oh, never mind. I think I did that next lesson. I'll take that back. Here we'll kind of dull. Let's see. 240 due east. Yoink. Plus. Matt, can you read to me the wind vector, magnitude, and direction, please?
125 meters a second at 40 degrees.
Yep.
Northwest.
North of what?
At west.
North of what?
West.
North of what?
At west.
That's the line I'm going to draw first. I'm going to draw a dotted line pointing west. What of west? How many degrees? So I'm going to eyeball it probably about there-ish, and that should be shorter, 125. I'll fix the scale once I break it down into components and then rewrite the numbers. Then I'll fix my scale. Did I say components? How do I know components? Because there's an angle. If you give me an angle, that's a job for components. So I'm going to break this up into Vx and Vy. I'll find Vx, I'll find Vy. Hopefully, oh, you know what? I can already tell you that 240, I'm going to subtract Vx from it because Vx is pointing in the opposite direction of 240. Yes? So I'll have to do a little winner minus loser. Then I'll combine that with Vy, and I'll get an answer. Is that okay? If you feel comfortable and you want to try going ahead, go ahead. I'm going to slowly talk my way through this, though. Vy, Vx, that's going to be adjacent, hypotenuse, opposite. I think sine 40 is going to be Vy over 125. So Vy is going to be 125 sine 40. $80.3486. Vx is going to be cos. Oh, you know what? Vx is going to be 125 cos 40 because it's the same thing but with cosine. Oh, cos 4, Mr. Duke. Oh, I could have just gone backspace and edited. That was dumb. Oh, well. And I get 95.7556. Yeah, am I wrong? Oh, 8.5, because I can't round off to save my life. Sarah, I owe you candy. I haven't done my shopping yet, but I owe you a candy. Was it Sarah or McKenna? Who spotted it? It was her? I owe you candy. I'll get you one. Remember, I owe you. Thank you. Thankfully, one of the reasons I carry extra decimals is if I make a dumb mistake there, hopefully it will make a difference once I go to 3 sig figs, hopefully. Yeah. So now if I break this up, I really have 240 plus 95.7556 plus 80.3485. Are there any of those, Lyndon, that I can combine easily? First two? Am I going to add them or am I going to go winner minus loser? Okay. Who's winning? Clearly. Oh, you know what? I happen to have this number stored on my calculator, so rather than using the 95.7556, I'll go minus, answer button. And I get 144.244. Still to the right. 144.244 plus 80.3485. What was that? I don't know. How am I going to draw this? Tip to tail, you say. Okay. And if this was 160, it'd be twice as big as 80. So I'll draw this almost but not quite twice as big as the 80, I think. So it's going to look something like this. Yoink. You like the sound effects, do you? I can go a little longer, I think. I did tell you that we were going to be using Pythagoras and trig an awful lot on all these questions a few days ago, I hope, because we are. This was, I think I called it V ground, yeah, VG. There it is. Little Pythagoras, little SOHCAHTOA, Bob's your uncle, so to speak. That's an old expression. That means easily done. Going to be this number squared plus 80.3485 squared square root 3 sig figs, 165 meters per second at tan theta equals 80.3485 over 144.244. Shift tan of 80.3485 over 144.244. Check for typos. I think I'm good. Do you get 29.1? Degrees, north of south, east of west, what of what? North of east, yes? It's a long question, but actually, if you break it up into steps, it's Math 8 and Math 9 just done about 5 times in a row. Little Pythagoras, little SOHCAHTOA trig, and just be careful. Last one and we're done. Just to let you know that all the stuff that we learned last year in Physics 11 still works in vector land. An object is initially moving at 6 meters per second due east. It accelerates due south at 3 meters per second squared for 4 seconds. Find V final by using VF equals VI plus AT. Okay. But now we got different directions. Do you see east? Do you see south? I'm going to throw compass rose on here just because. So apparently, VF is going to be VI. Nate, what's VI? Magnitude and direction. Plus AT, Nate, what's T? What's A? Direction? What's 4 times 3 south? Hey, last day I said it's easy to multiply a scalar onto a vector. You just multiply them. It's going to be 3 times 4, which is what? Direction? When I add those together, that will be V final. Still works. I just end up adding pictures instead of just going, what's VF, what's VI, and plugging them in mindlessly. It's going to be 6 over, 12 down, V final. V final is going to be 6 squared plus 12 squared square root. .4 meters per second at, there's my theta, opposite and adjacent again, tan again. Will it always be? Nope. Next lesson I'll show you when where it's not, because I'll give you the hypotenuse and you'll end up finding a leg. Tan theta is going to be .4. North of south, east of west, what of what? South of east. Which makes sense also. If you're going east initially and you accelerate south, you should end up going south of east. I'm good with that too. That makes intuitive sense to me. What's your homework? I already gave you, I think, sheet vector operations. So, on a separate piece of paper, try number 1, try number 2, try number 3. Number 4 is a pain because those ones you're going to have angles, which means you have to break them into components. I did these answer keys really, really, really rushed. I'm not convinced that I didn't make mistakes. I did these showing no work, doing it all on my calculator and trying to imagine everything in my head, and that's about where my limit, in fact, my limit's probably a half step before that. But I was in a rush and I wanted to give you some answers, and I just didn't have time to do a nice digital copy or anything like that. So take the answers with a grain of salt. I think they're good, but I was really rushing.